Reflecting solar cookers were developed at the University of Wisconsin's Solar Energy Laboratory to provide savings in fuel, cash, and forestry resources in sunny areas where such needs were felt. Under a Rockefeller Foundation grant to Dr. Milton Barnett, a team of anthropologists has been studying the acceptance and use of the solar cookers in 3 Mexican villages. In their last research village, the anthropologists developed a local production technology to increase the sample of cookers for their study, to facilitate cooker use after the study ended, and to assess whether reactions to the cooker would change if repairs and replacements could be made locally, and if some villagers were involved in cooker success. Thus, the villagers of Teotitlan del Valle in the Mexican state of Oaxaca were presented not only with a new artifact, but with a technology for producing it. A Teotitlan woman uses one of the cookers built and supplied by the Solar Energy Laboratory under the direction of Dr. J.A. Duffy. This model cooker itself resulted from earlier anthropological field study. It is lower and more conveniently accessible. It has more stability against wind or animals and is more durable than its laboratory predecessors. She focuses the parabolic reflector by accurately rotating and tilting it. Ground is cleared and leveled to provide a foundation for a convex mold. The parabolic reflector shells are shaped on such a mold, and careful preparation will provide a permanent mold on which one reflector after another can be shaped to specifications. The leveled ground is fortified with cement and packed by tamping. The convex mold will give a parabolic form to the reflectors so that they can properly concentrate the sun's rays on the cooker grill. Proper focusing of the solar cooker will furnish more than 500 watts of heat in favorable weather, the capacity of an ordinary electric hot plate. Plywood is used to make a parabolic scraping blade that will shape the mold. The parabola is drawn in a simple fashion using a carpenter's square. The dimensions of the parabola are determined vertically by the 45 centimeter or 1.5 foot focal length between the grill and the center of the reflector, and horizontally by the 60 centimeter or 2 foot reflector radius. Making the parabolic reflectors was the most unprecedented problem for the established craft technologies of the village, requiring the emergence of a previously non-existent specialist. The several technological stages shown are based on the suggestions of Dr. Farrington Daniels of the laboratory and those of anthropologists. However, numerous improvements were made by Fortino Oliveira, a village weaver shown here, who became the principal solar cooker builder and the specialist in the craft of making solar cookers. After the parabola is drawn, the scraping blade is sawed out so that it can be pivoted at the center of the mold and rotated to shape the mold through the various stages of its construction. Copper tubing edges the scraping blade in order for it to shape the final surface of the mold smoothly. Adjustment of numerous bolts permits the scraping blade to be clamped with great stability onto its pivot. The pivot is an iron rod that is pounded deeply into the ground and carefully checked with levels for absolute perpendicularity. When the blade has finally been lowered and leveled to its proper position, construction of the mold can be begun. First, concrete is mixed. Then rocks are piled around the pivot rod, and concrete is thrown around and on top of these rocks to make the resulting structure permanent. The rough parabolic outline of the emerging mold is constantly checked with the scraping blade. A layer of coarse concrete coats this rough mold, and its surface is carefully shaped by continuous rotation of the parabolic scraping blade. Low spots are filled in, ridges scraped down. A thin, almost pure cement coating is added as a final surface for the mold. It too is smoothed and shaped with the rotating blade. When dry, the finished mold is scraped and polished. Steel wool may be used, even wax. A layer of newspaper soaked with motor oil is used in Teotitlan del Valle to provide for separation between the mold and the reflector shell being produced. Any excess oil is carefully blotted off. Construction of the reflector shell is then begun using a liquid polyester resin plastic mixed with a drying accelerator. This will give a stiff and permanent shape to flexible materials such as fiberglass or cloth. In the village, a locally available muslin or manta is cut into triangular sections and laid on the mold. Every effort is made to avoid wrinkling. The cloth becomes saturated with the plastic already spread on the mold and with additional applications of plastic. It might be noted that both the plastic and accelerator are readily available in Mexico City, although the plastic is among the more costly items in local cooker buildings. These are the only items of the cooker being produced which could not be procured in Teotitlan or in the nearby markets at Oaxaca. Finally, a layer of burlap is laid on, and this too is soaked with plastic. Shells have been made of muslin alone and of burlap alone, but the mixture shown seems to provide the greatest strength for the amount of plastic used. To strengthen the reflector shell, particularly along its rim, an iron strap ring is built. A carpenter blacksmith in Teotitlan does this job. This is placed atop the still wet layers of muslin and burlap. The outer edges of these materials are then cut. After cutting, they're soaked with plastic and then carefully tucked up around the iron rim. The completed reflector shell must then be left to harden overnight before it can be removed from the mold. One of the carpenter blacksmiths makes a square U-shaped frame for the cooker. He marks, then saws, and finally will chisel notches out of the two wooden uprights that will be assembled with a crosspiece to make the frame. They will be fastened together with wooden pegs and with small supporting corner braces of iron. The design is the same as the tubular aluminum frame of the laboratory cooker shown earlier, so that the reflector hangs between the upright arms of the frame, and both frame and reflector rotate horizontally together for azimuth adjustment. They rotate around an iron rod embedded in the ground, and for this purpose, a heavy iron sleeve is bolted onto the frame. Another carpenter blacksmith marks one of the two iron strap lengths, which are then bent by pounding and further shaped by hand so as to form half circles at their centers. In building such cooker parts, the technological skills of already existing village craft specialists were simply turned to new tasks. And indeed, several modifications were made by the carpenter blacksmiths and were incorporated in Teotitlan cooker building as shown here. When the two iron strap parts are riveted together, they form a ring that will support the cooking vessel at the cooker's focal point. The remaining arms of this grilled crosspiece will rest on the upright arms of the square U-frame. From them, the reflector itself can swivel, always at focal length, which permits adjustment of its angle of elevation as desired. The new reflector shell, having hardened overnight, is slowly loosened and removed from the mold, which then becomes available for producing another reflector shell. The newspaper adhering to the shell is stripped off, or soaked with water and scraped off to make the concave surface of the shell completely smooth and ready for lining with some reflecting material. The carpenter blacksmith makes two flanges to suspend the reflector from the grilled crosspiece at the proper focal length. The focal length determines the length of these flanges and the location of the holes through which the grilled crosspiece arms are to pass. The flanges are bolted to opposite sides of the reflector shell through its iron strip rim. In assembling the cooker, The arms of the grill crosspiece are passed through the flange holes to provide suspensions for the reflector shell. To mount the cooker frame, its iron sleeve envelops a solid iron rod, previously pounded into the ground for all but a third of its 1 meter length. The cooker is here assembled to have its shell lined with a mosaic of mirrors. They are glued with the same polyester plastic used earlier. Those shown are 1-inch square, but larger mirrors, 4 or 5 centimeters square, are also successful. The mirrors must be cleaned of any dried plastic deposits or smudges, since these would diminish heating efficiency. Some cookers are lined with aluminized tapes like Mylar, Scotch-Cal, and Aclar. Such lightweight linings are required if a weaker, cheaper shell of paper mache is made. A rope is attached to the reflector rim and tied around the frame to control the reflector's elevation angle. Thus, another cooker is finished. You have seen the processes of this technological innovation, the local production of a solar cooker in Teotitlan del Valle. Cookers can be made in the village for between $5 and $16 and between 8 and 32 hours of labor, depending on the materials used. The cooker being focused by the woman is a forerunner of that whose production you just witnessed. Its plumber's piping and conduit tubing make it sturdier, more durable, but also more costly. This reflector is adjusted with a chain that hooks over a bolt on the frame. A pot of frijoles, or beans, is put on the grill, and the grease on the blackened bottom of the pot quickly begins to smoke as the cooker is focused. The beans come to a vigorous boil in the strong sun within 10 or 15 minutes. Successful continuance of this new technology at Teotitlan del Valle ultimately depends on the successful acceptance and use of the solar cookers themselves. However, the existence of a local village technology able to repair, replace, and multiply the cookers in use should prove an asset to their acceptance.